Okay, so 5-2 is still just a takeoff of what we saw on 5-1, just a little bit different, where you're actually going to see the words prove. And if you guys were geometry, you had to do proof step by step by step. Given this, then you need to show that it comes up to this. So we're going to start off with, instead of trig, we're actually going to just do it algebraically. And we're going to start with this second one here first. So what we have is we've got an expression off to the left that's equal to some expression here on the right. So we're going to go step by step to show that what's on the left does equal what's on the right. We're going to prove it, all right? So what we have on the left is two fractions, and when I have two fractions that are being added or subtracted, I need a common denominator. And my common denominator on those two fractions would be 2x. If all else fails, just multiply those denominators together. You get 2x. So the first thing I do on this side, the left fraction, my denominator is x. I need to be at 2x. So what am I going to multiply both numerator and denominator by? Multiply by 2. And I'm going to just show every step along the way. The fraction on the right, I'm going to multiply both by x over x. And I'm hoping that by the end, it's going to equal 2 minus x over 2x. So I get 2 over 2x minus 1 over 2x. I get 2 minus 1 all over 2x. There we go. 1 minus x actually equals x, not 1. My bad on that. So it's 2 minus x over 2x, which equals 2 minus x over 2x, and that does check. That is what we're going to be seeing in 2-2, 5-2, 5-2. Okay, so let's look at the second one, which is actually the one on the left. I had this all set up to do it nice and, you know, make it really difficult for you. And I had somebody in the last class, but Mrs. Meyer, can't we da-da-da-da-da? And I said, absolutely you can. And so going to look at this, it's going to come across not quite so difficult than what we had before, or what I actually had planned out. But what I have here is I've got x cubed minus x squared all over x. That in itself is a fraction, okay? That fraction is being subtracted, or x minus 1 times x plus 1 is being subtracted from that fraction. All of that is going to simplify down to 1 minus x, we hope. Because sometimes we'll get one that it doesn't work. Okay, so we're proving it. We're trying to see, does it actually work? So I think possibly one of the first things to do, let's multiply our binomials out. So we get x cubed minus x squared over x minus x times x is x squared. I've got a positive x and a negative x. They go away. Minus 1. Let's get rid of the parentheses. Let's distribute out the negative. So we get opposite of x squared plus 1. All right? So at this point, I was going, let's grab common denominators, you know, make this x cubed over x, make this x over x. Somebody see a different way in which to do that without having to deal with the denominator. That's what I was going to actually do, is to, well, the only way you can multiply it out is to get the common denominator, though. Is that what you mean by multiply it out?
I was thinking, I don't know if you can, since it's not over everything, but like if we multiplied x by both sides, could you do that? Or only if it's under everything?
Only it's under everything at this point. Because, I'm going to just bring this out here. I've got one term, my second term. Because they both have x's in there, I can actually cancel the x out from both. So I can take x cubed divided by x. What's that leave me with? X squared divided by x leaves me with
does that still work with the subtraction sign up top? Because you said
Right here?
in the last unit you said if there's those if subtraction or addition signs it doesn't work.
Correct.
I feel like it was like
If you can cancel from both of them, by all means do it.
oh yeah.
So if this was this, if it was x cubed minus 2 over x, you can't just cancel that. That's what I mean by that. Okay, good question. So what happens to my x squares? So I get opposite of x plus 1. Does that equal 1 minus x? It does. Check. Check. Okay, so now we have, that's what we're going to be doing, but we're going to be throwing it in with some trig identities. The graphing section that I have next on the notes, we're not going to actually do that together in class. What I would like you to do, though, is at some time, you know, Friday, Saturday night, you're sitting around, you're bored, you know, got your calculator handy, and you just want to play around, go for it. I want you to put this in as y1, and I want you to put this in as y2, and I want you to see what it looks like for them to be the same. Like you would only see one graph. So letting you know that these are the same, but my last one is not. And I want you to see what that looks like, okay, by playing with that in there. How can I type one or cotangent into my calculator?
When you just do 1 divided by tangent.
That's exactly what you would do. You have to take 1 divided by tangent. It's not inverse tangent, that's finding an angle measurement. Cotangent is 1 over tangent. So that's how you would have to put that into the calculator. And make sure that you have parentheses around that as well. Okay, so down below we have some strategies. Most of these we've seen before and heard before because we've talked about them in 5.1. But just to reiterate, we're starting fresh in 5.2. You want to begin, because what we're going to have is we're going to have one expression on one side and another expression on the other side. We want to make sure that they're equal. So it says to begin with the more complicated and work toward the less. Because if we have a pretty simple one, it's harder to pull that. Like here, if I have 1 minus x, what's there to work with on that? Not much. So we want to start with the more complicated side and work to the least complicated side, okay? So we want to begin with the more complicated, work toward the less. Number 2, if no other move suggests itself, convert the entire expression to sine and cosine. That's not new. That's not new. That's what we were doing all in 5.1. Number 3, not new. Combine fractions by putting them over a common denominator. And number 4, use the algebraic identity, and that's what we had to do up here with x minus 1 times x plus 1. We got x squared minus 1. And that is called difference of squares. You're going to see that quite a bit. Now, the difference between number 4 and the mistake you made, I say you, I say in general, all 4 classes, on the quiz with the 1 plus, it's because that was a plus. This is a minus. Okay, there's a difference there. Always be mindful of the target expression that bring you towards your goal. Okay, what can get me closer? All right, so here we have, on these two, we've got a Pythagorean identity that we're going to prove. And what's really kind of funny is that I can hand you a sheet of identities and I say here, and you guys just trust me so much, you believe that they're true. But in your generation, you're growing up with what's, you know, a saying, fake news. Well, how do you know that Mrs. Meyer didn't throw at you fake identities? So we are on a path today, a goal, in which we want to prove these identities to make sure that they're really not fake, okay? That I am giving you things that are true, all right? So we're going to start with the left side because that's more complicated, and we're going to try to get it to secant squared. All right, so we're going to start with 1 plus tangent squared. What can I do with that? There we go. Put it to sine and cosine. So 1 plus sine squared x over cosine squared x. Now, I am going to show every single step for notes. You do not have to show every single step, but, you know, the more you show, the more credit you'll get. So now I've got 1 plus a fraction. What do I do? What do I want to do with that 1? Cosine squared over cosine squared is the same thing as 1. I'm creating a common denominator. Well, first of all, was 1 plus tangent squared equals secant squared part of our identity sheet? Yeah. Oh my gosh, it was. Okay, so now that I have a common denominator, I have cosine squared x plus sine squared x on the numerator all over that common denominator of cosine x. That would be cosine squared x. And what is cosine squared x plus sine squared x? 1 over cosine squared x. And what is 1 over cosine squared x? Lucky there. She didn't lie to you after all. Truthful identities.
You could be lying about cosine squared x, but sine squared x equals 1.
I could be. You're right. We'll prove it.
That's okay.
We can go after that one. All right, so what I want you to do is on your own, just like what we did here, prove this one. 1 plus cotangent squared x plus cosecant squared x. And you should get a check, just like that. Okay, questions on those identities? Those two. Yep.
Are we gonna do it?
Yep.
How many?
Every single one of them in the next 10 minutes. Because we're so good.
Thank you.
We're so good. All right, on the back. Change, you get that, honey? Okay. Okay. On all honesty, we're just going to do this one. Because this one is a little different. And don't you love it? And that's the way math is. We give you all these 5 good hints on how to prove something and to show that it's true. And then I'm going to say, well, yeah, just kidding for this one. This one is different, okay? Everything that we have, probably every problem, somehow, some way, I've given you one. Well, really, you don't write it in cosine and sine for this one. We actually turn it to secant. Remember that one? I said take your cosine squared and turn it to secant squared. Yeah, okay. Well, this is kind of like that. But before we start on this one, what I want you to do is actually number these 1, 2, 3, 4, 5 on the back so it's easier when we go to refer to them. And then I want you to compare the number 1 equation with number 2 equation. What's the difference in the setup, the overall general setup between the two of them? What does number 2 have that number 1 does not?
A sine by itself?
Okay, something completely by itself over here. They're adding the fractions here. Is there any adding fractions on number 1? It is one fraction set equal to another fraction. Do you all see that? It's really important that you see that because of the way we're going to solve this. And I'm going to be using a phrase that is probably one of the most annoying phrases that I can think of in mathematics because it is the most misused method in solving problems, and that is called, I even hate to say it, cross multiplication. It just shivers, because it's so misused. The only time that you should be using cross multiplication is when you have one fraction equal to another fraction. That's it. We want to cross multiply here. Now, to do that, to get a common denominator, great, but not to solve. But to solve, the only time that we can do that is when you have one ratio set equal to another. And I've got it here. So that is a method in which to solve, okay? So what I'm going to do is I'm going to take sine times sine, and I get sine squared. Set that equal to 1 plus cosine x times 1 minus cosine x. And I'm going to see now if what's on the right will equal what's on the left. Sine squared equals 1 times 1 is 1. I got a negative cosine, positive cosine, those cancel out. Cosine times negative cosine is negative cosine squared x. What does negative cosine squared x equal? Sine squared x. Check. We are finished. And that is only because I have a fraction equal to a fraction. Okay? I've got a ratio equal to a ratio, a fraction equal to a fraction. All right?